Hello, I'm Reva. Today I'll be talking about science process skills. Basic skills for science, that is process skills. Science is a process by which scientists collectively and over time endeavor to construct and accumulate reliable, consistent and objective representation of the world. The processes that scientists use in it are science process skills. Science is important to all young people for not only to acquire the knowledge associated with it, but also to imbibe its inquiry and process skills. These skills enable them to develop into adults who are able to take informed and responsible action while engaging and reflecting upon different ideas, opinions, beliefs, or values. These are long-lasting, thus tend to be useful throughout each area of our lives. These skills involve the use of all the sense organs, providing hands-on experiences for enjoyable and effective learning. What are the science process skills? Science process skills are defined as a set of broadly transferable abilities appropriate to many science disciplines and reflective of the behavior of scientists. Science process skills refer to the following actions without any particular order, such as observation, communication, classification, measurement, inference, and prediction. Applying these skills, one can conduct objective investigation and reach at conclusions based on the results. These are integrated together when scientists design and carry out experiments. All these basic skills are important individually as well as when they are integrated. Types of social process skills. The basic process skills provide a foundation for learning the integrated skills. These skills are: number one, observing. Observing means using the senses to gather information about an object or event. We make observations every day. An observation is knowledge that can be acquired using any of our five senses. Sight is one of our five senses. This is when we see with our eyes. Some things we can see are color, shape, and number of objects. For example, describing a leaf as green, a photo frame as square, and 6 apples in a basket as number. Hearing is another sense. We hear different sounds with our ears, such as a fire alarm or the crunching of a leaf that was just stepped on. Touch, a third sense, is the sense of touch. The 4 types of touch sensations are hot, cold, pain, and contact. Smell is the sense we use our nose for. We can smell an odor or the scent of food. We use our tongue for the sense of taste. The different types of taste are sweet, sour, bitter, and salty. Qualitative and quantitative observations. There are 2 types of observations: qualitative and quantitative. A qualitative observation describes a quality of an object such as color or shape. A quantitative observation describes the amount of an object present, for example, volume or mass. Inferring is another process skill. Inferring, what is an inference? An inference is an interpretation or an explanation of an observation. The observation is made using our senses. To make an inference, we connect what we observed to prior knowledge and the new information observed through our senses. An inference can be made from more than one observation, and it is not just a guess. Inferring is making an educated guess about an object or event based on previously gathered data or information. The inferring process involves following steps. What did I observe? What do I really know? How can my knowledge explain what I observed? What does this mean? For example, if you see someone eating a new food and he or she makes a face, then you infer he does not like it. Or if someone slams a door, you can infer that she is upset about something. Thus, we can say that an inference is a reasonable but tentative conclusion or explanation about objects, organisms, events, or causes based on one's prior knowledge. Inferring allows students to make educated assumptions or conclusions based on reasonable explanations when a complete set of data is not present. For instance, when conducting and recording observations about the weather, students could notice wet roads and sidewalks on their way to school. They would infer that it has rained during the night, even though they did not actually see it rain. They would, however, still note the rain in their weather chart. Measuring is another process skill. Measurement is the process of quantifying observations and includes distance, mass, volume, area, time, and temperature. Measuring is usually done with non-standard units and standard units. Length or distance in one dimension, that is height, perimeter, width, etc., is the simplest and most concrete measurement for most young children to understand. Measuring, therefore, is using both standard and non-standard measures or estimates to describe the dimensions of an object or event. For example, using a meter stick to measure the length of a table in centimeters. What is this metric system? The metric system is used universally throughout the science world. The word metric stems from the base unit of a meter. Some of the base units of the metric system are: base unit for measuring length is the meter, represented by small m. Base unit for measuring volume is the liter, that is L. Base unit for measuring mass is the kilogram, kg. When measuring temperature, scientists use the metric unit of Celsius. Measurement tools. So let us have a look at different types of measurement tools that we use for measurement purposes. A meter stick is used to measure length. There are 100 centimeters in 1 meter and 10 millimeters in 1 centimeter. A graduated cylinder is used to measure volume, can go anywhere from 0 to 100 and in any form, must read at eye level and read at the meniscus line. Thermometers are used to measure temperature. Temperature in the metric system is measured in degrees Celsius. Non-standard units of measurement. What are these? Non-standard units of measurement are units of measurement that aren't typically used, such as a pencil, an arm, a toothpick, or a brick. Communicating is an essential skill because students will almost always in any subject or real-life situation need to explain their reasoning, description, or explanation in a clear and understandable way. Communicating can involve presenting information to others in a variety of ways, including written tests, oral discussions, symbols, metaphors, and demonstrations. Communication also includes being able to communicate information through charts, graphs, and other models. Scientists present and communicate their findings in scientific journals, conference presentations, online publications, and other means of collaboration or peer review. The Internet provides similar opportunities for students through online project collaboration sites, email with experts, and video conferencing with other classrooms. Students learn how oral and written communication are used in science. They are given tips for communicating in science and they practice communicating skills using words or graphic symbols to describe an action, object, or event. For example, describing the change in height of a plant over time in writing or through a graph or diagrams. Classifying is one more process skill. Why is classification important? Classifying things into different categories prevents new information from getting lost. We categorize by recognizing similarities and differences between things and how they relate to one another. Classification is the basis for all concept formation. Students need to know how to classify because students often need to group objects or organisms based on one or more common properties. This skill allows them to understand the differences and similarities between items of study. For instance, students might classify plant samples in various ways: color, bloom date, location, quantity, genus, and so forth, to find patterns for early blooming. Classifying, therefore, is grouping or ordering objects or events into categories based on properties or criteria. For example, placing all rocks having certain grain size or hardness into one group. Stages of classification. There are 3 stages of classification. Single stage classification. What does it mean? It involves separating a set of objects into two or more subsets based on at least one observable property. For example, clouds are classified into three basic groups: cumulus, stratus, and cirrus clouds. Binary classification is a specific type of single-stage classification. In this simple classification, objects are sorted into two groups based on whether or not they have a certain property. Multi-stage classification. In this, sets are sorted into subsets, then each of those subsets is sorted again and again. This creates several layers or stages of subsets. For example, animals that may have been grouped as vertebrates may be separated again into groups of reptiles, birds, mammals, pisces, and amphibians. These are all subsets of vertebrates. Serial ordering. Objects are placed in order by the extent to which they have a certain property. For example, rocks may be placed in order from smallest to largest or lightest to heaviest. Predicting. Predicting is another important process skill. What is a prediction? A prediction is a guess about what might happen in the future based on observations that you make. Predicting is closely related to other process skills such as observing, inferring, and classifying. Many process skills are in fact dependent on other process skills. For example, it is cloudy, so I predict it is going to rain today. Thus, predicting is stating the outcome of a future event based on a pattern of evidence. For example, predicting the height of a plant in 2 weeks' time based on a graph of its growth during the previous 4 weeks. Students need to know how to use current knowledge and data patterns to make educated guesses on probable outcomes of investigation. Predicting allows students to form a hypothesis, ask relevant questions, and begin studying in a particular direction. Predicting allows students to extend limited experiments to further studies, such as extrapolating what will occur in further studies of evaporation based on a limited experiment. When making a prediction, use your senses to observe and collect data or information. Notice any patterns through classification. Make connections to your knowledge. Predict what you think will happen in the future based on these things. Integrated science process skills. Let us have a look at these skills now. Controlling variables. It means being able to identify variables that can affect an experimental outcome, keeping most constant while manipulating only the independent variable. For example, realizing through past experiences that amount of light and water need to be controlled when testing to see how the addition of organic matter affects the growth of beans. Defining operationally. It means stating how to measure a variable in an experiment. An operational definition of a variable describes what is observed, what is measured. These definitions are written quantitatively using length, width, height, etc., time, distance, temperature, numerical value of something. For example, stating that bean growth will be measured in centimeters per week. To gain a better understanding of what an operational definition is, let us consider the following example. Researchers in sports medicine and exercise physiology study the effects of various variables on a person's endurance. Each researcher might decide on a different way of measuring this variable. For example, if an experiment was conducted to test the effects of vitamin E on endurance, the dependent variable being the person's endurance might be operationally defined in ways such as the distance a person could run without stopping, the number of hours a person could stay awake, the number of jumping jacks a person could do before getting tired. Formulating hypothesis is another process skill. It means stating the expected outcome of an experiment. For example, the greater the amount of organic matter added to the soil, the greater the bean growth. A testable hypothesis should point toward the design of an experiment to test whether that hypothesis is correct or incorrect. A hypothesis is an educated guess. Unlike a wild guess, an educated guess is based on prior knowledge and observations. Interpreting data is one more important skill. It means organizing data and drawing conclusions from it. For example, recording data from the experiment on mean growth in a data table and forming a conclusion which relates trends in the data to variables. Constructing a data table. How do we do it? When constructing a data table, there are no absolute rules, but there are commonly agreed upon organization patterns. One such example is that the independent variable is recorded in the left column and the dependent variable is recorded in the right column. Data is usually ordered from smallest to largest or largest to smallest. This helps us see a pattern between the changing independent variables and the dependent variables. Most experiments should be repeated by testing each level of the independent variables several times. Repeated trials reduce the effects of chance errors that sometimes occur in a single trial. Transferring data from a table to a graph. Let's see how we do it. This is an easy two-step process in which you observe the data in the data table and write number pairs. Use the number pairs to locate the data points on a graph. Graphs show trends and patterns more effectively than just a table because they are more visual. When writing data pairs, the value for the horizontal x-axis is written first, followed by the vertical y-axis. Here is a data table for you. Experimenting is one of the very important process skills. An experiment is a procedure carefully designed to test a hypothesis. The procedure should yield data that either supports or does not support a hypothesis. Experimenting puts together all the science process skills. Experiments begin as a question and then follow steps to answer the question. These steps include identifying variables, formulating hypotheses, identifying factors, defining variables operationally, designing an investigation, conducting repeated trials, collecting data, analyzing and interpreting data collected. For example, the entire process of conducting the experiment on the effect of organic matter on the growth of a particular species of plants. Drawing conclusions. When drawing conclusions from an experiment, it is important to remember that words are always written in complete sentences, measurements are always written with units, pictures are drawn carefully. After the students conduct an experiment, they should question why certain results occurred, such as what was the purpose of the experiment, was the hypothesis supported by the data, what were the major findings, include a clear statement describing the relationship between the independent and dependent variables, were there any outside factors that could have affected the results, how could the experiment be improved, and so on. Now we will talk about some other skills to be developed in students in interconnected world. We all know that the world is connected with the help of technology these days. So here the first skill that we will talk about is information processing skills. The information age helps to develop literacy and thinking skills using technology appropriately and ethically and working as part of a team as well as independently. Problem solving and critical thinking skills. These skills need to be practiced in the context of day-to-day experiences. Each student must know problem solving, that is defining a problem, designing, developing and determining the solution. Technology can help the teachers to make students work on their own, think on their own and resolve issues on their own. We have to move them from a culture of dependency to a culture of independency. Communication skills using modern technology. Let's have a look at this skill. Such skills are very important in the age of technology where people have to communicate their message to others at distant places. Over and about technological reading and writing are different processes from literary reading and writing. It is the difference between reading a novel and reading information on a screen, writing an essay versus designing teaching learning experiences or drawing a graph. These skills need to be developed by bringing their relevance to the various concepts of science. These skills should be integrated into the curriculum to deal with increasingly technical and iconic world, both online and offline. Technology as a tool and not as a subject. What do we mean? So while developing teaching learning experiences, one has to be cautious that contextualized use of these experiences is for learning rather than focusing on hardware and software. The technology needs to be exploited based on learning needs rather than technology being the driver. Developing information literacy. Facilitating all students to know how to become judicious users of information in an era of information age by empowering them with the skills such as asking, accessing, analyzing, authenticating, and assessing. Helping students to make informed decisions. This again is a skill. Students should be helped to explore and gather information from various sources, analyze the given information, and select the required data to make informed decisions based on the problem to be solved. Learning to understand interpersonal and intrapersonal skills. Opportunities should be provided to students for learning goal setting, self-assessment, entrepreneurship, team spirit, and collaborative work. Thus, proper use of information and communication technology can shift the role of a teacher from providing information passively to creating and generating learning environment for individual student as per her requirement and learning style. This can help a student to construct her own knowledge. Students can conceptualize the situation and arrive at the solution of a problem. However, learning is definitely affected by the learning environment and context, attitude and self-motivation of the learner. Therefore, it is important that the teacher provides learning experiences through developed materials, reviewed sites, reviewed web pages, and facilitate interaction with her peer groups. So, what is the role of teacher in present times? The teacher has an important role to play in providing children with some important points. Let's see what these points are. Children should be given various opportunities to develop process skills of science. Action provides the practical basis for thinking. For example, simply telling what it means to observe, investigate, experiment, and interpret have no meaning until given an opportunity to try these. Opportunities for discussion in small or large groups and in the whole class may be provided. These allow children to listen to others, explain, argue, express, and share their ideas, thus involving them in thinking what they have done, relating to the evidence, and considering multiple ways of approaching a problem. To help children develop process skills, it is important for the teacher to know how children are using those skills. The teacher can observe their work and listen to their discussions to pick up information on how children have collected and used the evidence. The children need to realize the area of the skills in which they need improvement. For this, they may be allowed to discuss their investigation and critically reflect on it. The teacher can encourage them to try alternative courses of action for improvement. For increasing accuracy in acquisition of some skills, there may be a need for introducing new techniques and tools. For example, for measurement of different quantities, children require various instruments such as balance, vernier calipers, screw gauge, thermometers, graphs, etc. To conclude, I hope that today's talk will help you in practicing these basic science process skills and enable you to help your students practice the same. Please remember that role of teacher is very important in the lives of students. So, your contribution would go a long way in shaping their personalities. Thank you.